we'll look at some fundamentals first. We'll consider the fundamentals of the topics. I'll show you what the syllabus says you should be able to do. Then we'll look at the fundamentals of the topics. Then we'll do examples, look at past question paper, and we'll look at how to apply the fundamentals to solving the problem. So fundamentals, application, that's how we'll flow with this. Okay, so we're going to be focusing on chemical energetics. Okay, I know you have prior knowledge, but I'm just going to take it from the scratch and be asking you questions along the line, chemical energetics. So according to your syllabus, you're expected to be able to, do this. So this is what your syllabus says. You have for the core and the extendable. We are taking everything together. So we're going to cover all of these, okay? Especially the 6.1, okay? The 6.2, it's just simple things you could read up, not technical thing there in 6.2. So we can focus on this 6.1. It's going to be very, very productive, okay? Very productive. So you should be able to describe the meaning of exothermic and endothermic reaction. You should be able to interpret energy level diagrams showing exothermic and endothermic reactions. Then you should be able to describe bond breaking as endothermic and bond forming as exothermic. You should be able to draw and label, consider energy level diagrams for exothermic and endothermic reaction using data provided. And lastly, you should be able to calculate the energy of a reaction using bond energies. Okay, so describe the release of heat energy by bonding fuels. Those ones are a bit simple. So let's focus on the 6.1 within the time frame that we have, so that you know that it's sorted once and for all. Those of you that just joined, you're welcome, but you joined so late. Okay, so the first part of it, let's take the first part of it. So as I teach and move on, if you do not get anything, just stop me immediately and ask questions. Just interrupt and ask questions. Then I'll be able to reinforce that particular aspect, okay? So I'll try to move as, at a very good, moderately okay speed so that you can get the nitty-gritty. So the first part of it here says, you should be able to describe exothermic and endothermic reaction, describing exo and endothermic reaction. So if you recall a few of the things that you did in terms of types of chemical, reaction. So you give an example of endothermic reaction and exothermic reaction. As a giving examples for each of them. Does anyone want to give us an example of a reaction that you know is exothermic? Do you want to give an example of a reaction you know from your previous knowledge that you think it's exothermic reaction? Anybody? Looking at exothermic.
Combustion.
Okay. That's Shane, right?
Yes.
Okay. So I'm not combustion reaction. Okay, combustion reaction. That's an exothermic reaction, very spontaneous, kind of chemical reaction, combustion reaction. Okay, it's a spontaneous kind of chemical reaction. Look at this, reaction. What kind of reaction would you call this reaction? What kind of reaction would that be? Or can somebody describe this reaction? Just describe it. What description will you give to this reaction? Anyone?
Can you say it's
exothermic?
Oh yeah, it's exothermic reaction, but I want you to describe the reaction. Just say something about the reaction.
It's a combustion reaction, like there's flames. I don't know.
Okay.
An explosion.
Okay, so So basically you're saying this reaction is explosive, right? Is explosive, right? Okay. So apart from the fact that you saw lights, what other thing do you think could be part of this reaction?
Oxygen.
What?
I don't know. But like there was smoke, so I thought maybe like
Smoke,
oxygen.
yes. Smoke, you release smoke, yes. Any other thing. So if a reaction is explosive, release great deal of light and release smoke, what other thing do you think will accompany that? What other thing will accompany such a reaction? Any other form of energy? I'm leading you on now. Any other form of
energy.
Okay, it's going to release what? Heat. Okay, heat energy. So when you say a reaction is exothermic, exothermic. So if you break the word down, the word exo means external, okay, out. While the word thermic refers to what? Thermal, okay, and that is what? Heat, okay. So if a chemical reaction occurs and such a reaction releases heat energy, you call such a reaction an exothermic reaction. So we say that exothermic, okay, reaction is such that what? Releases heat energy, okay? Releases what? Heat energy. So if a reaction releases heat energy, what will happen to the temperature of the surroundings or of the reaction mixture or vessel?
It's going to increase.
Okay, so the temperature will increase. So we can say that for exothermic reaction is accompanied by what? Increase in what? Increase in temperature. So if a reaction occurs and the temperature increases, then you say such a reaction is what? An exothermic what? Reaction. So the reaction occurs and heat energy is what? Is released. Such a reaction is said to be an exothermic what? Reaction. Okay, so just first we are looking at meaning. What does it mean? Before we now look at the nitty-gritty of it, okay? So let's look at endothermic reaction. Endothermic reaction. So let's assume that I have a reaction in a test tube, okay? Reaction in a test tube. This is the start of the experiment, okay? I mix two things together in a test tube, let's say A and B together in a test tube, and I started, initial temperature was 25 degrees Celsius. So when the reaction took place, the reaction has taken place. Now in the test tube, we measured the temperature of the test tube and we found out that it is 20 degrees Celsius. Okay, this is the end of the reaction, while this is the start of the reaction. So if you look at this, what is the change in temperature that we have? What is the change in temperature? Oh, okay, yeah, got the idea of final minus initial. Okay, so we have, well, 5 degrees Celsius, right? So she said -5, so let's just put in -5 degree Celsius. Okay, so in this particular kind of chemical reaction where you have a decrease in temperature, that minus means that you have a decrease in temperature. Such a reaction is said to be what? An endothermic reaction. Please, I need you to look at that word very well. Endothermic. Just like we did for the other one, endo means inside. Okay, inside. That means to internalize. To internalize. Of course, your thermal here has to do with what? Heat energy. Okay, so when your heat energy is absorbed into something, the heat energy in the surrounding, okay, is drawn into, is taken in. Yeah, that's a good word. taken in. The heat energy is taken in. Okay, so we'll call this kind of reaction an endothermic reaction. So in an endothermic reaction, what happens to heat energy? Endothermic reaction, heat energy is what? Heat energy is absorbed, right? Yeah, heat energy is absorbed, it's taken in. So that is why it is minus. I mean, in terms of decrease in temperature, so let me just stick to the word decrease in temperature. That's why the temperature decreases. It means that the temperature went somewhere. The temperature was hidden somewhere, was swallowed and internalized, so we no longer could see it. So 5 degrees Celsius, okay, represent the amount of heat energy that was absorbed by something, that was taken in. So we say such a reaction is an endothermic reaction because heat energy is what is absorbed. And this reaction is accompanied by what? A decrease in what? In temperature. It's accompanied by a decrease in temperature. So in terms of meaning, I want to be sure that the meaning of endo and exo is cleared. Okay. Now, to go ahead to reinforce what I just explained here. For chemical reactions, because you may be asking, the heat energy absorbed, okay, goes where? Or the heat energy released is coming from where? So I need to quickly explain the energy conversion. Please, you need to be very, attentive here. Energy conversion. So you must remember the fact that energy can be converted from one form to another. Energy is not really destroyed. It can be converted from one form to another. So if I have a reaction like this, say reactants, okay, come together to form products and releases energy. The formation of product is accompanied by the release of energy. This energy, of course, is what? Is heat energy. Okay, the question is, because energy can be converted from one form to another. So I need to look at this. This reactant, the energy in the reactant is in the form of chemical what? Energy. Energy in the reactant is in the form of chemical energy. The energy in the product is in the form of what? Chemical what? Chemical energy. But this other energy is what? Heat energy. So if you look at it, we can conclude that the chemical energy, let's assume that represent, the unit energy can be represented in joule, right? So let's say we have 50 joule of energy, chemical energy in this reactant. But when the reaction progressed and it formed products and the reaction ended, I have 40 joule of product, that is the chemical energy in the product, 40 joule, then this other energy will be 10 joule because of the law of conservation of what? Energy. Energy is neither created nor destroyed. It is converted from one form to another. So if you look at this reaction now, basically we are saying that a reaction that releases heat energy is said to be what? An exothermic reaction. So this is an exothermic reaction. So the reactant is converted to product and it releases what? Energy in form of heat energy. This is the heat energy that your thermometer measures to tell us, oh, there is an increase in what? In temperature. So for this kind of reaction, you may have started with 20 degrees Celsius, but at the end of the day, you may end with say 30 degrees Celsius. So the question is, where did that heat energy come from? The heat energy comes from converting your chemical energy to what? To the heat energy. So your chemical energy is converted to what? To heat energy. That is for your what? Exothermic reaction. So when it comes to endothermic reaction, the reverse will be the case. So for your endothermic reaction, your reactants okay, starting there, will require what? Heat energy. They will absorb heat energy. They will take it in to form what? To form product. Can you see that? Your reactant will absorb heat energy. That is why we say in endothermic reaction, energy is absorbed. Energy is taken in. So your reactant absorbs what? Heat energy for the reaction to progress. So let's assume that I started with let's say, let me just do the reverse, 40 joule here, and we add 10 joule of heat energy. Maybe we heated it up. It will be expected that we have 50 joule of what? Of energy. But this 50 joule of energy, your thermometer cannot measure it because it is chemical energy. Your thermometer can only measure what? Heat energy. Your thermometer cannot measure chemical what? Chemical energy. Can only measure heat energy. So in that case, in that situation, in that case, what do we have to do or explain? So we are saying that if I start this reaction, let's say at say 30 degrees Celsius, okay, 30 degrees Celsius. Now, your reactant is going to take out of this 30, okay, take it in as well heat energy, such that at the end of the day, we have 20 degrees Celsius when the reaction has taken place. That means that 10 degree energy was what? Absorbed. 10 degree was absorbed of energy, of heat energy was absorbed, because the difference between the starting temperature and the final temperature is 10 degrees Celsius. So we are now saying that this reaction absorbs what? Heat energy. So that leads to a decrease in what? Temperature. But it leads to an increase in chemical what? Energy. Decrease in temperature and increase in chemical energy. So I see chemical energy change from what? From 40 to what? 50. So I need you to understand chemical energetics in that concept, in that light. So when we go to the next thing that your syllabus says you should be able to do, that is drawing energy diagram. This explanation that I made here will help you to comprehend, because sometimes it might look confusing. How will something lose heat energy? Okay, lose heat energy, and we'll expect the temperature to be increasing. We say it's losing heat energy, and yet the temperature is increasing. It looks confusing, but it is simple, easy to understand. If, for example, I have heat energy on the inside of me, or energy on the inside of me, but you cannot measure, your thermometer cannot measure what is on my inside. Your thermometer can only measure what is on my outside. So if I put the thermometer on my face, okay, the thermometer is reading 20 degrees Celsius. I put on my face, is reading 20 degrees Celsius. So if it is exothermic reaction, if I release heat energy from inside of me, I'm losing what is inside, I'm losing it out. When that heat energy comes out, my thermometer will pick it up and the temperature will increase. So, yes?
Mr. Gunti, I can't hear you. Hello, Mr. Gunti.
Yes, please, others, can you hear me?
Yes, I can hear you.
So please look at your audio. Others can hear me. Okay, so that is the concept. If I have a container, for example, this is a case. Okay, this is a case. Now I have a chemical on the inside of it. Okay, now I close it up. I put the thermometer on the outside. Don't forget, your thermometer can only measure heat energy. Thermometer cannot measure chemical energy, and your chemical energy is inside the reactant or the product. So I put the thermometer here at the start of the experiment. My thermometer is measuring 20 degrees Celsius. So, but I want to use this to explain exo. If it's an exothermic reaction, we are saying that the temperature will increase. What that simply means that the temperature of the surrounding will increase. Why would the temperature increase? Because energy would have come out of this container, okay, come out of it, be lost from this container. And when the energy is lost, it stays outside, my thermometer picks it up. Okay, my thermometer picks it up, and when the thermometer picks it up, the temperature will increase. That explains why you have your 20 increasing to 30. You can see that because heat energy is lost. So that heat energy lost is coming from where? It's coming from the inside, the chemical. So chemical energy is converted to heat energy in exothermic reaction. But in endothermic reaction, heat energy will be converted to a form of chemical energy, which will be added up to 40 to make what? To make 50. So we can see in endothermic reaction, heat energy is absorbed. In exothermic reaction, heat energy is lost. Okay, that's just the summary. In exothermic reaction, temperature is increased. In endothermic reaction, temperature is decreased. So I hope that is taken, guys. Any questions so far? Any question? If you are fine, just say I'm okay.
I'm good.
Okay, thank you. Thank you. So let's progress now. The next, last Shimilori. That sounded like Shimilori. Okay.
Oh, it was the head boy. Children.
Oh, head boy, how are you?
I'm good, Mr.
Okay. So now let's progress. The next thing in your syllabus says you should be able to interpret energy level diagrams showing exothermic and endothermic reactions. So you have a whole lot of this in objective questions. They love so much drawing energy level diagrams. So it might look simple, but you don't need to lose any single mark, okay? So you should be able to interpret energy level diagrams showing exothermic and endothermic reaction. Now, the concept that I explained to you guys about energy conversion comes in here, and it helps you to understand the concept of energy level diagram, okay? So if you look at this energy level diagram, this is your energy, while this is the reaction progress. If you like, you can say time, okay? Just reaction progress, how the reaction progresses, okay? So want to show, now let's pick possibly an exothermic reaction. So let's pick exothermic reaction first. So we want to show energy level diagram for exothermic reaction. Say energy level diagram, or energy diagram if you like. Energy diagram, okay, for what? For exothermic. Exothermic. Now, if you look at this diagram that you have here, okay, you would see that you have your reactant is higher than the product. Reactant is higher than the product. And we said that exothermic reaction is accompanied by what? Increase in temperature. So a whole lot of students get confused. Like, what if it's accompanied by increase in temperature? Then how come you are saying the energy goes down? So the way I explain it to students is this, and I need to listen. The energy level diagram is actually expressed in the context of chemical energy in the reactant and product, even though the textbook won't say that expressly. Okay, so if I was to write one, that's the expression to make you understand that the energy level diagram expresses chemical what? Energy. Expresses chemical energy. Okay, now let's start it together. So let's draw ours and let's see. So I have here, okay, so I'm starting with, say, a reactant here. Let me represent my reactant with R. Okay, so I'm starting with R. I will say that for your exothermic reaction, heat energy will be what? Will be lost. Heat energy will be lost. So the question is, where will the heat energy come from? The heat energy comes from the conversion of chemical energy, which is expressed here as just energy. Okay, so this is, let me say, chemical energy. So the chemical energy for this reaction, let me measure this as 50 joule. At 50 joule, that was initial. So out of this chemical energy, if 20 joule out of it is converted to heat energy, it will still be 20 joule of heat energy, but it is no longer 20 joule of what? Chemical energy. Okay, so that heat energy would be lost. So we use a downward arrow to show a decrease in chemical energy that is losing. So it goes down. So if it times out, please just use the same link to join again. Okay, so I have a decrease in what? In chemical energy. Okay, so I have a loss of what? Chemical energy. Okay, then now my product, this is where my product is. So the energy, the chemical energy remaining in my product, okay, remaining in my product is now, let's say, 20 joule remaining in my product. Okay, so the question is, this gap that I have here, the gap that I have here is that this chemical energy is lost, but in what form? It is lost in form of what? Heat energy. Okay, so if it is lost in form of heat energy, I would expect that when I started the reaction, maybe I started the reaction at 10 degrees Celsius. At the end of the day, I may get something like 20 degrees Celsius because heat energy is now available, which was not available before. Heat energy is now available. So my thermometer picks up the heat energy. Unfortunately, thermometer cannot measure chemical energy. So here, it remains as 10 degrees Celsius until something happened that converts the chemical energy to what? To heat energy. So here, my thermometer picks it up and say, okay, 20 degrees Celsius, the temperature now is 20 degrees Celsius. That means I have 10 degrees Celsius increase in what? In temperature. Okay? Of course, you should know that there is a connection between temperature and what? And thermal energy. Okay? For example, if those who do physics among you talk about measuring heat capacity or specific heat capacity, and you do a conversion, so you do your mass multiplied by what? Specific capacity times what? Change in temperature. So your temperature change multiplied by the mass of the substance and the specific capacity can be converted to what? To chemical energy. That is amount of energy. Okay? So, but essentially here, I hope you guys understand why it looks as if in exothermic reaction, the temperature is increasing. Yet, when I'm drawing the diagram, I'm saying my product is lower than what? Than reactant. The reason why the product is lower than reactant is because the energy that is lost in form of heat energy that is seen as increase in heat energy actually came from a loss of what? Chemical energy. Guys, I hope the concept is simple, is it?
Understand it.
Okay, guys. Thank you. So that's just the basics, very simple. So in case you are confused about that, just look at the concept in terms of energy conversion and you'll be able to get it. So basically, if we are to make a summary here, okay, for energy profile, we'll just say that the energy of what? Energy of product, okay, is lesser than what? Lesser than energy of reactant for exothermic. Energy of reactant. That is the summary of what? Energy profile for what? Exothermic reaction. Okay, so let's move on to what? Energy profile for endothermic reaction. Endothermic reaction. Okay, so these fundamentals for endothermic reaction. So we'll quickly consider endothermic what reaction. So we are now looking at energy diagram. Okay, diagram for endo. Okay, if you put things down, fine. If not, I could share this slide with you guys later. Okay, so energy diagram for what? Endothermic reaction. So the same thing here. Okay, so let's draw our own. Okay, so you have it like this. So let's say I'm starting with a reactant. Of course, you know reactant, I'll use R. Now, back to your fundamental of endo. We say endothermic reaction does what? Absorb what? heat energy. So that means that my heat energy is coming from the surrounding. Heat energy is coming from where? From the surrounding. Okay, so the heat energy from the surrounding, it could be from the fire, Bunsen burner, or from your palm, from wherever. Heat energy is given to the what? To the reactant. Okay, so when the reactant absorbs the heat energy, the reactant converts the heat energy to chemical energy. Then there will be an increase in what? In chemical what? Energy of the reactant. So as the reaction progresses, the chemical energy forms a what? I mean, the reactant will form what? The product. So you would see here that the energy of the product will be higher than what? Energy of the reactant. But the difference here, the difference that we'll call delta H, that is enthalpy change. The difference here is as a result of the fact that heat energy from outside was absorbed by the word reactant. So the reactant converts to chemical energy, then the chemical energy increases on the scale. So the product has more chemical energy than what? Than the reactant, because something was absorbed and that thing was added to the reactant to form the what? To form the product. So how does that, you have been able to see now that the energy of the product is higher than what? Energy of the reactant for endothermic reaction. But how come we say for endothermic reaction there is a decrease in temperature? Now this is what will make it obvious. Okay, so if for endothermic reaction, I started with 20 degrees Celsius, and at the end of the day, we end with what? 10 degrees Celsius. What that simply means is that the heat energy that we have here was taken in and used and was converted to chemical what? Energy. So you would expect the temperature to go down, because if your heat energy is decreasing, the temperature will decrease. So heat energy was consumed. Heat energy was swallowed in, was internalized. That is why it is endo, was internalized, swallowed up by the chemical. So no more heat energy, or heat energy has decreased. So you would expect that the temperature will go down, will decrease. So that is the connection. Let's make a summary for this. So the summary is for your endothermic reaction, the energy, okay, energy of your product, okay, is what? Is higher than what? Than reactant. If the Zoom times out, just use the link to join again, please. Okay, energy of reactant. And also, it is accompanied by what? There is a what? A decrease. There is a decrease in what? In temperature. Okay, so yeah, so I think that basically explains we have looked at two aspects of your syllabus learning outcome now. So the next fundamentals we'll consider will be bond breaking and what? Bond formation. Bond breaking and bond formation. But I need to quickly say something before it times us out. So this change in energy for your endothermic reaction is usually positive. Positive. You can see that it increases. You can see there's an increase. So that means positive. That means something is added to it. It is swallowed, added to it. So it is usually represented by what? Positive change, plus. So if you do energy of product minus reactant, let's say this is 50 and this is 30. So if you do 50 minus 30, you're going to get plus 20, plus 20. So that tells you that what? For endothermic reaction, enthalpy change. This is the symbol for what? Enthalpy change. I hope you can still remember. This is just a revision class. Okay. Enthalpy what? Enthalpy change. Enthalpy change for endothermic reaction is usually what? Is usually positive. So for your exothermic reaction, the enthalpy change, which is the delta H, it will be what? Negative. Negative. Why will it be negative? Because the product is lesser than the word reactant, and your enthalpy change is usually final minus initial, which is product minus reactant in this case. Okay, and that will give you what? A negative value. Because if I started from 50, started from 50, now I'm 20. So 20 minus 50 is expected to give me what? Minus what? Minus 30 joule. So your exothermic reaction is represented or identified by a negative sign. You have less than 1 minute to time out. So you could think, just reflect over this. Then when we log in again, we'll move on to bond breaking and bond formation after the timeout. So anybody want to ask question for a few seconds timeout?